In this part of the lecture, you'll learn how to solve quadratic equations by factorization. We'll start by stating the general form of the quadratic equation, which looks like this. ax squared plus bx plus c is equal to 0. A, b and c are called coefficients. They're all constant values. In order for it to be a quadratic equation, there must be an x squared term. If there's no x squared term, it's not a quadratic, it's something else. We'll have a look at a number of different cases. We'll examine ax squared plus bx equals 0. And how to solve that by factorization, we'll call that case 1. The second case will be x squared plus bx plus c is equal to 0. That is, the coefficient of x squared, a, is equal to 1. We'll call that case 2. In the third case, we'll see what happens when b is 0, and we want to solve the quadratic x squared minus c is equal to 0. We'll call that case 3. Lastly, we'll revisit our general form of the quadratic, and we'll call that case 4. So in the first case, we want to consider a quadratic of the form ax squared plus bx is equal to 0. In other words, the constant term c is equal to 0. As our example, we'll choose 2x squared minus 6x equals 0. If we look at the two terms of this equation, we can see that we've got a common factor of 2x. So we'll take the common factor out and we'll rewrite this as 2x into x minus 3 is equal to 0. Just by looking at it, we can see that either x must equal 0 or x minus 3 is going to equal 0, in which case x would equal 3. So our two solutions are x equals 0 and x equals 3. Let's move on to case 2. In the second case, we'll consider the coefficient of x squared, a, is equal to 1. So we have an equation of the form x squared plus bx plus c is equal to 0. As an example, we'll solve x squared plus 2x minus 24 is equal to 0. There's a neat trick that we can apply in the case where a is equal to 1 in order to find the numbers that go inside our brackets. Obviously, we're going to have an x here in both brackets, but we need to know the number and the sign that goes into each bracket. The trick we can apply is to find the factors of negative 24, which add up to 2. Or in general terms, what we're doing is finding the factors of c, which add up to b. And I need to stress, this only works in the case where a is equal to 1. So factors of negative 24, which add up to 2, well, of course, that's going to be 6 and negative 4. So we can write this as x plus 6 and x minus 4. Setting the brackets equal to 0, we can now write down the solutions. X is equal to negative 6, or x is equal to 4. In case 3, we're going to consider a quadratic where the coefficient of x, that is b, is equal to 0. We'll consider as an example x squared minus 16 is equal to 0. How are we going to factorize this? Can we still apply the trick that we used in case 2 and find the factors of c which add up to b? Well, of course we can, because b is equal to 0, isn't it? So we can write the two brackets down, with an x in each one. So we want the factors of negative 16, which will add up to 0, minus 4, and plus or positive 4. So the solutions, in this case, are going to be x equals 4 and x equals negative 4. A quadratic expressed in this particular form is sometimes called the difference between squares. Obviously, the c in this case is a perfect square. Moving on to case 4 then. This is the most general form of the quadratic equation. Ax squared plus bx plus c is equal to 0. So we're going to have a look at factorizing this when a is not equal to 1. As an example, we'll look at 6x squared plus 11x minus 10 is equal to 0. As a is not equal to 1, we can't use the trick that we used before, but we can use a modified version of this. And actually what we want to do is find the factors of AC which add up to B. We'll take that as our first step. So let's just write that down. Find the factors of AC that add up to B. So we'll call that step one. So it's useful to remember that. AC is equal to 6 times negative 10, so that's going to be negative 60. And of course, B is equal to positive 11. So we want the factors of negative 60, which add up to 11. They're going to be minus 4 and 15. These two numbers, we can't use them directly as we did in the previous two cases. What we're going to do instead is use them to separate the 11x into two separate terms. And we're going to rewrite our equation. We'll call this step 2. We'll rewrite this as 6x squared plus 15x minus 4x minus 10 is equal to 0. That's the reason why we found the factors of AC that add up to B, because we want to rewrite it in this form. And now we've done that, our third step is to factorize the pairs of terms. So if we look at 6x squared and 15x, we can write that as 3x multiplied by x plus 5. And then a minus 4x and minus 10, we can take out minus 2. Sorry, that's going to be 2x there, isn't it? 3x multiplied by 2x plus 5. So we take out minus 2, and we write that as 2x plus 5. Okay, so we've now got a common factor of 2x plus 5. So we can factorize this again. We'll call this step 4. And we can rewrite this as 3x minus 2 into 2x plus 5. So now we can write down our two solutions, and we're going to have x is equal to 2/3, or x is equal to minus 5 over 2. Okay, so you've learned how to factorize quadratic equations when they're expressed in 4 different forms. You should now have a go at the multiple choice exercise following this subsection.